Okay, this is chapter 14, the third series. This is the last lecture. And we want to discuss now what is the pH change of a buffer if we add acid. So this is a problem that's lacking from the lecture guide, but basically we have a buffer that's composed of sodium bicarbonate and sodium carbonate, and we want to add a drop of hydrochloric acid. Now we're going to assume the volume change doesn't matter, and in fact it doesn't. If you add water to a buffer, the concentrations change, but the molar amount, the moles of the amounts of substances don't, so the pH doesn't change if you add pure water. But here we're going to add HCl, and we're going to go ahead and calculate this. So again, remember when you're deciding what your buffer is, we've got sodium bicarbonate, which is a neutral spectator ion of sodium ion, and bicarbonate, which is HCO3 negative. Sodium carbonate has the formula Na2CO3, which is composed of two neutral sodium ions and carbonate. And remember again, we decide which one's the acid based on how many hydrogens we have. Bicarbonate is the acid, carbonate is the base, and if we look at Appendix 3 in the lecture guide, we can see that the pKa of bicarbonate, make sure bicarbonate is in the acid column. If you have bicarbonate in the acid column and you move your finger over to the right, you will see that the pKa is 10.3. Okay, this is a weak acid. So what we want to do now is calculate moles of the substances. I'm always going to use moles for my calculations. So to do that, what you want to do is convert the molarity, which is moles per liter, and one of these will be sodium bicarbonate. And this is in a 500 milliliter volume. 500 milliliters is 0.500 liters. Okay. And what you get here is 0.100 moles of bicarbonate. Okay, and I will just write it as the ion there. The same thing for carbonate. So we have Na2CO3. We have 0.500 liters. Liters cancels, and we're left with this many moles of carbonate. Okay. Now, HCl that we're adding here is an acid. Okay. And the acid that you add, HCl, will react with the base. Okay. So if you add HCl, it reacts with your weak base in the buffer. The acid here is just going to hang out and not react. So when we set up an ice table, it's going to look like this. Your first step generally starts with here. You write the balanced chemical reaction. So we have carbonate. Okay, and that's what we're labeling as our weak base. Okay, we're adding hydrochloric acid. The chloride is a neutral, it's a neutral substance. Chloride is a -1, anion, but it's a neutral substance. H plus is the reactive part of the hydrochloric acid, and these two will come together to give you bicarbonate. Okay, so this is the reaction you want to have when you're adding H plus. So this comes from your HCl. Okay, and this over here is the conjugate base, the conjugate acid of your weak base. So it's a weak acid and a weak base here. And we want to set up our ice table here. And the initial amounts, we want to grab our 0.100 moles or 0.100 moles. Okay, and for HCl, that's up here in green, we got a very small amount, 0.0015 moles. Okay. Now remember what we talked about. You look at these two numbers and you decide which one is the limiting reactant. This is smaller, so that's the limiting reactant. And so all of that gets used up, so we want to subtract 0.0015 and subtract 0.0015 from the reactants, which get used up as they proceed in this reaction from left to right. And on the right side of this chemical equation, we're going to form 0.0015 of the bicarbonate. All of the coefficients here are 1. So what we're basically doing is subtracting x from the two left reactants and adding x to the product. And we know what x is. X is equal to, this amount here. Now what we need to do is go ahead and add the columns. So you do that here now, 0.985. And this comes out to be 0. And this becomes 0.1015. Okay? Now what we want to do here is use the Henderson-Hasselbalch equation. So the pH is equal to the pKa plus log of the base over the acid. Okay, and which one's the base, which one's the acid, right? We've already have it labeled up here. The base is the carbonate and the weak acid is the bicarbonate. So we want to plug this in. Remember what we did up above is that we figured out what the pKa of this acid is. It's 10.3. Okay, so that's 10.3, and that comes from Appendix 3. And then we want to take the log of this ratio. So put the base on top. It's easy to get these mixed up. 0.0985. So that's the base. And the acid is 0.1015. And we're using the final amounts after the chemical reaction. Okay. Let's go ahead and do that on our calculator. When I do this, I get 10.3, and over here I get minus 0.01. Okay, so you can see how the value is going to be 10.29 when you round things off. Okay, and you do a little check here. The initial pH, I didn't do the math, but the initial pH is equal to 10.3, and it went down to 10.29. And so if you add acid, the pH is going to drop, which is more acidic. Okay? So it's going to make the solution more acidic. More acidic means lower pH. Okay, so let me do another practice problem with you here. All right, say we have a buffer and we're going to add a bit of HCl to this. meant to say sodium acetate here. Okay, so what is the pH after 0.050 moles of HCl is added to a buffer made from 0.16 moles of acetic acid and 0.20 moles of sodium acetate. Okay, so we're going to label this as the base, right? Because it has fewer hydrogens, and this one's labeled as the acid. So when we add HCl, which is an acid, it's going to react with this. So those are going to be on the left side of the chemical reaction. I'm going to write acetate. I'm going to discard the sodium. I'm going to write H+. I'm going to discard the Cl- of the hydrochloric acid. And that's going to form acetic acid, a little bit more of it. Okay. Now we already have the molar amount, so I can plug those in here into the ice table. This is step 1. So acetate has a concentration or a molar amount of 0.20. Acetic acid has a mole amount of 0.16, and I'm adding HCl. I'm adding 0.050 moles. Okay, that's a very small amount compared to the 0.2. That's my limiting reactant. Okay, and I want to add my columns here. Okay, and I've got my final mole amounts of the base and the acid. Now, we want to look at Appendix 3 and find out what the pKa is for acetic acid, and that's 4.74 according to my Appendix 3. And we'll want to then plug this in to our Henderson-Hasselbalch equation, and that's log of the base over the acid. Make sure you're doing the log of that fraction, so use parentheses on your calculator when you do this. So that's 4.74 plus log of 0.15 over 0.21. And let's see what we get here. I get a value of 4.59. Okay. All right, so let's get a lecture problem in here for you. Let's say we have a buffer composed of benzoic acid and sodium benzoate. Okay. Calculate the pH of this buffer. Calculate the pH of the buffer above after 0.25 moles of HCl is added. Okay, and go ahead and enter those on your worksheet to verify that you've watched the video and understand things. And this concludes chapter 14. Thanks for watching.